Welcome everyone. I am S. Venkatesh, Assistant Professor in Department of Computer Science and Engineering from JJ College of Engineering and Technology, Tiruchirappalli, Tamil Nadu. I am going to present a video lecture on the subject CCS 334 Big Data Analytics. So in this video lecture, let me cover the following topics: crowdsourcing analytics, key value data model, failures in classic MapReduce and Yarn, architecture of Hadoop distributed file system, and architecture, features and applications of HBase. First of all, we should know what is meant by big data. Big data means it refers to large as well as complex data sets. These data sets are extremely difficult to capture or to store or to coordinate or manage or analyze using the usual traditional tools used for data processing. Big data is characterized by three V's. The first V is volume, that is amount of data. Second V is velocity, that is speed of data generation, and third V is variety, that is different types of data. Big data analytics. So big data analytics is the process of examining this big data, that is large and complex data sets. The purpose is to uncover hidden patterns, what is the correlation in between them, the trends and other insights. Big data analytics leverages advanced tools and techniques like machine learning, statistical analysis and data mining to support decision making as well as strategic planning. Let's see few real-time applications of big data analytics. The first one is fraud detection in banking. It identifies suspicious transactions instantly. Next one is traffic and route optimization. Big data analytics uses live GPS data to manage congestion as well as it suggests the best routes. Next one is healthcare monitoring. It analyzes patient vitals in real time for emergency alerts. The fourth one is social media trends analysis. Big data analytics tracks viral content as well as public sentiment as it happens. Next one is stock market prediction. It responds to live trading data for dynamic investment decisions. Next one is cyber security threat detection. It monitors network traffic in real time to identify and block potential threats. Next one is e-commerce personalization. As per our wish, we can personalize the e-commerce data. So the first unit in big data analytics subject is understanding big data. In that we are going to cover the topic crowdsourcing analytics. So in crowdsourcing analytics we are going to cover what is the meaning of crowdsourcing analytics, real world examples, its types, advantages, disadvantages and conclusion. So first of all, crowdsourcing analytics means it is a method. It is used to integrate large scale human participation with data analytics for the purpose of gathering, processing and interpreting data. It leverages the collective intelligence of distributed participants through digital platforms. The aim is to generate insights and to solve complex problems. It is used particularly when data needs to be gathered quickly from a wide demographic or in real-time environments. So it is used for rapid data collection. It is enabled by internet, smartphones, cloud and social media. Crowdsourcing analytics is frequently used in business intelligence, disaster response, scientific research and market prediction. Let's see some real world examples. First one is Google Maps. So it utilizes real-time location data from mobile users. The purpose is to analyze traffic conditions, estimate travel time and suggest alternative routes. Next one is what we know very well, that is Wikipedia. It maintains a constantly evolving knowledge base by allowing global users to edit and contribute content. Next one is Amazon M-Turk or Mechanical Turk. It offers businesses the ability to distribute tasks such as image classification or survey analysis to a large group of workers. Next one is Waze. It relies on drivers to report traffic issues, accidents and hazards to improve navigation recommendations. Next one is Foldit. It encourages players to solve puzzles related to the protein folding. It contributes to biological research. The sixth one is Zooniverse. It engages the public to help researchers for classifying images and transcript historical texts. Next real world example is Duolingo. It translates web content by using language learners' responses as a crowdsourced translation mechanism. Next, Netflix challenge. It is once used as a public challenge to crowdsource better recommendation algorithms. Then OpenStreetMap. It builds a collaborative map. It allows users to contribute geographic data from GPS and local knowledge. The last one is Crisis Mapping. It collects information from the public during disasters. It is used for visualizing and analyzing crisis situations in real time. Now we will see the types of crowdsourcing. Wisdom of the crowd. It involves collecting knowledge or opinions from a large group of people. The aim is to reach more accurate solution. It is often used in prediction markets, forecasting models and decision making. The second type is crowd creation. It focuses on content creation such as videos, designs, software code and articles. It is common in innovation platforms, open source software as well as design competitions. The third type is crowd voting. It is used to gather public opinion through voting mechanisms. It can be applied in product testing, idea validation, talent shows and marketing campaigns. Next type is crowdfunding. It gathers financial contributions from a large number of supporters. It is used to fund startups, creative projects and community initiatives. The popular platforms are Kickstarter, GoFundMe and Indiegogo. Next type is crowdfunding. What we have seen now. Just like crowdfunding, we have one more thing, namely crowd testing. That is, it engages users from diverse environments. It is used to test software applications as well as products in real world conditions. It also enhances product reliability by uncovering usability issues. The next type is crowd curation. It uses community judgment to rank, filter or organize content or data. It is seen in platforms like Reddit, Stack Overflow and Quora, where voting determines content visibility. Next one is crowd translation. It utilizes multilingual communities to translate documents, subtitles and content across languages. It uses tools like Transifex or platforms like TED Translation. Next one is advantages of crowdsourcing. So it is cost effective. It reduces the need for internal resources or specialized equipment. Then scalability, it easily scales up data collection. Then speed, it accelerates data collection and problem solving in time sensitive situations. Next, diverse input, gains access to varied perspectives and expertise across discipline and cultures. Next, innovation boost, encourages unconventional thinking and novel solutions through open participation. Real-time insights, it provides up-to-date data streams useful in dynamic decision making. Flexible applications in fields ranging from healthcare and education to marketing and policy planning. Now we will see the disadvantages of crowdsourcing. Data quality issues. Contributions may be inaccurate or manipulated. Then lack of accountability. Anonymous contributors may not ensure reliability. Then bias and representation. Certain groups may dominate contributions affecting representativeness. Security and privacy risks. Data collection from the public may raise concerns over privacy, consent and misuse. Coordination complexity. Managing large-scale participation requires structured workflows and moderation. Then IP conflicts, that is intellectual property conflicts. Disputes may arise over who is the owner of the ideas or data. Then motivation challenges. Volunteer-based models may suffer from inconsistency in contributor engagement. Conclusion. Crowdsourcing analytics, it harnesses the collective potential of distributed participants. It enhances the depth and scale of data analysis. Its integration into big data frameworks contributes to real-time decision making, innovation and dynamic problem solving. Despite some challenges, it remains a valuable strategy. It is complemented with proper validation techniques, incentive models and ethical safeguards. Now we will go to second unit, NoSQL data management in big data analytics. The topic is key value data model. We are going to cover the introduction about key value data model, role in big data, some real-time examples, then advantages and disadvantages with conclusion. So here we see a diagram. So first of all, what is meant by key value data model? So it is a fundamental type of NoSQL database architecture. It is used in big data analytics for storing data as a collection of key value pairs. Here each unique key is associated with a specific value. So here you can see key, they are given as name, gender and city, and the value for name is Raja, gender is male and city is Trichy. So here we have key value data model. The keys are mapped to the values, name is mapped to Raja, gender is to male and city is to Trichy. So the key value data model is a NoSQL database architecture, as I said already. So here we have key as well as value pairs. They are associated with each other. So it offers a simple and highly flexible mechanism for data storage as well as retrieval. It allows rapid access to information based on the key. So key value stores, they do not require a fixed schema, making them highly suitable for dynamic or semi-structured data. Each value can be a primitive data type like a number or a string, or a complex object like a JSON document or binary large objects. So due to their scalability and performance, key value stores are commonly employed in distributed computing environments, especially for large-scale web applications, caching systems and real-time data processing. Its role in big data. So it enables fast data access. Here we are going to use unique keys. It scales horizontally. So we are going to use this in distributed systems. So as we expect, it is a flexible one without a fixed schema. So we can manage millions and billions of records using this technique. So it is built for high performance, and it supports caching, session storage and user data. So it supports high speed operations with horizontal scalability, so making it ideal for handling vast volumes of data generated from IoT devices, social media platforms, e-commerce websites and financial systems. Now we will see the real world examples of key value data model. First one is Amazon DynamoDB. So it is a fully managed NoSQL database service. It uses the key value model. It provides low latency data access at any scale. It is used by major e-commerce platforms for managing user sessions, shopping cart data and product recommendations. Next, Redis. It is an in-memory data structure store. It is often used as a cache or message broker. It is frequently adopted in high-performance applications for session storage, real-time analytics, and leaderboard management in gaming. React KV. It is designed for fault tolerance and scalability, suitable for applications needing high availability. It is used in telecommunications. It is used in healthcare to store user preferences and transactional metadata. Goldmark. It is developed by LinkedIn. It is a distributed key value data storage system. It is used to store important user metadata and recommendation engine inputs. Next, Berkeley DB. It is a high performance embedded key value database often used in financial systems for transactional processing. Now let's move to the advantages of key value data model. So the horizontal scalability across multiple servers is the major advantage. So simplicity, that is the data structure is straightforward, making development, integration and maintenance easier for scalable systems. Next one is it supports automatic partitioning and replication, that is duplication. So there is no rigid schema, so you can dynamically change it based on the evolving data. Efficient for storing frequently accessed data. So whatever data you are going to access frequently, there you can use this concept in caching layers. So here you are not going to use rigid schema. So commonly it enhances system responsiveness and it reduces latency. Then it reduces database load and it is used to improve responsiveness. So for large volumes it will support. Then built-in replication for fault tolerance. So many key value databases are designed with built-in replication and data distribution mechanisms. It ensures high availability even in the event of node or hardware failures. Then support for large volumes. It is capable of managing billions of key value pairs efficiently. So it makes suitable for big data environments. So it is efficient at managing millions and billions of key value pairs. So due to the capability to support large volumes, it is optimized for big data environments. Next one is disadvantages of key value data model. So it is limited. So there is limited complex querying capabilities. That is compared to relational databases. So the queries typically require a known key. It restricts use in scenarios demanding multi-key joins or advanced filtering. So this flat structure leads to potential data redundancy. That is, some data duplication may occur, increasing the storage overhead. No native support for relationships or joins. So unlike relational models, key value stores do not support foreign keys or referential integrity, not well suited for applications requiring complex relationships between entities. Difficult to perform groupings or analytics without extra tools. So that is, performing aggregations, groupings or analytical queries requires additional layers of processing or integration with other tools. Then complex application logic. Without a schema, the responsibility for managing data structure and validation shifts to application layer, increasing development complexity. Then many key value stores offer limited support for ACID transactions. It can be a constraint in applications needing strict consistency. Then challenges in migration. Migrating to or from a key value model can be difficult due to its unstructured nature, especially when dealing with legacy systems. Conclusion: the key value data model is a core component of NoSQL ecosystem. It plays a crucial role in enabling fast, scalable and flexible data handling. Its simplicity and performance can make it ideal to use in use cases which involves high volume, low latency access patterns such as caching, session management and real-time analytics. The trade-offs in query capabilities, transactional guarantees and relationship modeling require careful consideration when selecting this model for complex applications. So choosing a key value store should be driven by the needs of the system. It includes access patterns, consistency requirements and expected data growth. When used appropriately, the key value databases can enhance the efficiency of data-driven systems at a massive scale.